Hello. In this video, we'll see examples of some of the problem-solving strategies. So if you look at your lesson plan, there's a total of 13 problem-solving strategies. So I will do examples of 3 of those to be systematic, to look for patterns, and try a simple version of the problem. So we're going to do an example of the problem-solving strategy to be systematic. Okay, this is the strategy. If you approach a situation in an organized, systematic way, frequently you will gain insight into the problem. Here's the example. That's example 4 in the book. Suppose that Nico is considering which optional features to include with his new smartphone. He has narrowed it down to 3 choices: multiple screens, multiple cameras, and artificial intelligence photo editing. Depending on price, he will decide how many of these options he can afford. Question: in how many ways can he make his decision? So we are going to organize all the possibility. This means that Nico has the following possibilities. So Nico has the following possibilities: that his new phone has no features, it has only one, it has 2 but not all 3, and that it has all 3. So we are going to organize this information in a table. And one of the strategies was to give names to unknowns. So using the strategy of giving name to unknowns, we are going to call S is going to stand for multiple screens. C is going to stand for multiple cameras. And A for artificial intelligence photo editing. Okay, so let's see where we are. These are going to be the features: multiple screens, multiple cameras, and artificial intelligence photo editing. So the possibility is that it has no features, that it has only one, that it has 2 but not all 3, and that it has all 3. Okay, suppose that, if the phone has no features, that can only happen in one way, that it has none of those. If it has one, that can happen in 3 ways: that it has multiple screens, but not the other 2. That it has multiple cameras, but it doesn't have none of the other 2. And that it has artificial AI photo editing, but none of the other 2. Okay, so this thing froze a little bit. We just need to give it a couple of seconds so I can keep writing. Okay, there it is. So it has 2, but not 3. Okay, so these are the ways in which the font can have two features. Now I need more space. Or in which the font can have one feature. We have two more cases. So two features when it has two but not three. So one possibility that it has multiple screens and multiple cameras, but no AI photo editing. Or it has multiple cameras and AI photo editing, or it doesn't have multiple screens, but it has the other two. And three features that can only happen in one way. So counting all the possibilities, we have a total of 8. That means Nico, or there are 8 ways that Nico can make his decision. So again, we're reading again the strategy of be systematic. If you approach a situation in an organized, systematic way, frequently you will gain insight into the problem. The next strategy is to look for patterns. And in the video included on my MATLAB, I have an example of the Pascal triangle. I'll do a different type, identifying patterns. So let's copy the strategy. And then I'll copy the problems. So if you can recognize a pattern in a situation you're studying, you can often use it to answer questions about that situation. So let's see. So I'm looking for the next problem. And here they are. So I'll copy the directions. These are the problems at the end. And I'm going to write down the page number. And we're doing number 20, 21, 20 and 21. So some of these problems have more than one solution. Not all of them, but some. So in the following exercises, I'm taking this from page 15. So in the following exercises, in the next two, continue the pattern for 5 more items in the list. And there may be more than one way to continue the pattern. For example, in number 20, we have 1, 3, 9, 27. So if you identify the pattern, you can see that the previous number is multiplied by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So the next one should be 81. 27 times 3 is 81. And that's it. Now, number 21, it could happen in different ways. I'm just going to give you the solution that is in the back of the book. But we have AB, AC, AD, and AE. And then we have BC, BD, BE. So one possibility could be this. Oh, 5 more items. Actually, we're not done. 5 more items. 81 times 3 is 243. 243 times 3 is 729. 729 times 3 is 2,187. And 2,187 times 3 is 6,561. And now the next one, number 21. One way to see it, and this is the solution that they have at the end of in the back of the book, is that we have a letter and the next letter that follow that letter. For example, the four letters following A are B, C, D, and E. And then they stop there, and the next first letter is B. So the four letters that follow B are C, D, E, and F. The next one is going to be C. And the letters following C are D, E, F, and G. Again, this is not the only one, but that's well, that's the answer they have, and that's what I could identify as well. That's the letter and the four letters that follow it. And the other example that I'm going to do is an example of trying a smaller version or a simpler version of the problem. And I'll do the example that follows about the bank branches. So you can begin to understand a complex problem by solving some scaled down versions of the problem. Once you recognize a pattern in the way you're solving the simple problems, you can carry over this insight to attack the full-blown problem. So we are going to go over example 6. Let's suppose that 12 branches of Bank of America need secure communication links among them so that financial transfers can be made safely. How many links are necessary? So 12 branches are a lot. I mean, that's a lot to try to do all at once. So instead of doing all 12, we're going to start with a smaller number and identify a pattern. So instead of trying all 12, we can start with a small all 12 branches. We can start with a smaller number. And identify a pattern. So this is what we're going to do. We're going to start, okay, we're going to make a table. And we're going to start with one branch. So we're going to have a table with the number of branches, the branches themselves, the links, and at the end, we're going to have the number of links. Okay, so let's start with one branch. If there's one branch, let's call the branch A. Well, there is no link. There is no link if there's only one branch. I mean, linking a branch with itself, there's no need to do that. So there are no links. If there are two branches, let's call them A and B. There's only one way to link those branches, AB. So there's one link. If there are three branches and we link them 2 by 2, let's say that the branches are A, B, and C. There are 3 ways to link the branches 2 by 2, and those are AB, AC, and BC. So that's a total of 3 branches. Okay, if it's still not clear, we can try 4. The branches are A, B, C, and D. So the links are going to be AB, AC, AD, and then we have, those are the branches with A. AB is the same as BA, so the next one is going to be BC, BD, then CA is the same as AC, CB is the same as BC, so the last one is going to be CD. There's a total of 6 links. Okay, so this is going somewhere, and I'll do one more. And if you haven't seen the pattern, we're going to do one more. Remember, we have a total of 12. So I'll do one more with 5. The branches are A, B, C, D, and D. So we link them 2 by 2. We have A, AB, AC, AD, and A. AB and BA are the same, so the next ones are BC, BD, and B. Then the ones with C, CA is the same as AC, CB is the same as BC. The next ones are CD and C. And the last one is going to be D. We have everything else that includes branch D. So that's a total of 10. And I could keep going. But here's the pattern. The pattern is the following. That's one way to see it. That's one way to say it. That as we add more branches, the number of links increase by 1, then 2, then 3, and so on. So let's summarize what we have done, and we're going to use this pattern to find the 12 branches. So the question is, what about the 12 branches? So this is where we are now. We did it so far, we did it for 5. But if we increase the number, there's going to be a lot of writing. So we have the number of branches. Okay, this is the pound symbol. And the number of links. And our findings, okay, we have this up to 12. 1, 2, 3, up to 12. Okay, we found that with one branch, there are no links. With 2 branches, there's 1 link. If there are 3 branches, there are 3 links. 4 branches, 6 links, and 5 branches, 10 links. So another way to see it is that if we add the numbers in the columns, we get the next one. For example, 1 plus 0 is 1. 2 plus 1 is 3. 3 plus 3 is 6. 4 plus 6 is 10. 5 plus 10 is 15. 6 plus 15 is 21. 21 plus 7 is 28. 28 plus 8 is 36. 36 plus 9 is 45. 45 plus 10 is 55. And 55 plus 11 is 66. So for 12 branches, final answer, If that's for 12 branches, there will be 66 links. Okay, thank you for listening.